Okay, good morning. So let's start our session straight away. So in the last sessions also we were solving problems. In this session also we will be doing the same thing because engineering graphics is mostly about drawing things. As I said earlier, it is mostly about drawing things and understanding the concepts behind what is happening. But because of this online mode, it is very difficult to make you understand the concepts. So that's why I tried a different way in the sense using the base figure, we are trying to solve the problems. And as the complexity of the problems increases, the way in which we have to understand the base figure, that also changes. Changes means in the problems to come, that is in many problems, I'm not saying that in all the problems, but in many problems to come, the shape of the figure may not be the same as the shape of the base figure. We have seen such a case in one of the previous examples in which the point B is closer to the VP, or the point B was lying in VP. In that case, the shape of our final drawing was different from the shape of our base figure, or the orientation of the lines in the base figure. So that sort of what you say, non-conformities will be happening in the problems to come also. The only thing is you have to understand the basic idea behind the figure, the base figure, that is the points which are lying in the same straight line, the lines which are having the same length, etc., etc. That things you have to understand from the base figure, and based on that thing we are solving the problems. So in the problems to come, there may be some non-conformities with the base figure. So it is not because of the problems or because of errors in the problem or errors in the way we write or we draw the problems, or it is a problem with the base figure. No, nothing like that. Everything is perfect. The only difference is that the base figure is just a representation of the relationship between various points as well as various lines or various curves in that particular figure, or in the way the projection of lines is drawn or projection of lines is done. So let's move on to the next exercise. So I hope you are comfortable with this method of teaching. Otherwise, if I try to make you understand the basic concept, it will be very difficult. So that's why I am sticking to this method. And I hope, yesterday I went through some of your drawings that you uploaded in the Google Classroom. And it is from those figures, what I understood is most of you are able to draw it. May not be all of you, but most of you are able to draw it and understand or read the base figure, so that you can solve a problem maybe on your own also. So that sort of things we will try out in the next week or so, after the first during the first internal exam. In the next week we will be you will be facing the first internal exam, and during that time you will be facing how to solve a problem on your own. So before one second, is it what? Okay. Sorry, the power here went off, so I thought the internet connection also got disconnected. No, nothing like that. Okay. So when we are doing some problems like this, what you have to do is you have to first mark the data that is given in the question into the base figure, and then based on those data you have to draw it. That we are doing it. So let's do another example, another exercise. The top view of a 75 millimeter long line CD measures 50 millimeter. End C is in HP and 50 millimeter in front of VP. End D is 15 millimeter in front of VP and it is above HP. Draw projections of CD and find angles. That means find the inclinations with HP and VP. So you just note down the question. Okay, now with the base figure, let's denote which are the different dimensions that is given. So top view of a 75 millimeter long line CD measures 50 millimeter, which means the true length, the actual length of the line's true length is 75 millimeter. So this is also 75. So the true length is 75, that is given. And the top view measures 50 millimeter. So the top view length, the length of the top view is 50 millimeter. So these two data are there. End C is in HP. Instead of A and B, here we use C and D. So C dash corresponds to A dash and D dash corresponds to B dash. And small letter C corresponds to A and small letter D corresponds to B, like that, likewise. So end C is in HP means this distance, the distance of C dash from XY should be 0. That is, this distance should be 0. That is A dash or C dash. C dash will be lying in the XY line. And end D is 15 millimeter in front of VP and it is above HP. So that means end D, that is this point, this point, that is in this case a point B. It is 15 millimeter in front of VP. That means this distance should be 15 millimeter. And it is said that it is above HP. Above HP means it should be, that is the B dash should be above the XY line. So these are the conditions that is given. So there are 5 data, 75 is one, 15 is the second one, 50 is the third one, and the fourth one is 0, and then the last one is it is above the HP, that is also there. So draw the projections CD and find the angles HP and VP. And D is 15 millimeter in front of it. Okay. So yeah, end C, the distance of end C is also given. Sorry, I missed it out. End C is in HP, that is this is 0 and 50 millimeter in front of VP, that is this distance. This distance is 50 millimeter. So that is, there are 5 different data that are given: 75, 0, 50, 15, and 50. So 5 different data are there. So now how to solve it? So with all these points, with all these dimensions, first what we can do is we can first mark A dash as well as A, because the distance of A dash from XY is given, A from XY is given. So that part we can do. Whenever we can find out the projections of a single point, whether it is an endpoint or it can be HT or VT, then first what we do is we mark that particular point, that is the front view as well as the top view of the same point. If the VT or HT is given, in that case also we can mark the front view as well as top view of that point, because HT is given, so HT you can mark and then H dash you can mark. If VT is given, VT you can mark, then V you can mark. In this particular case, one endpoint is given. So that is the point C is given. C is in HP and 50 millimeter in front of VP. So you can easily mark C dash as well as C. It is the top view C. That also you can mark. So that is the first condition that we apply to this type of problems. If a specific point, if two projections, both the projections, that is the front view as well as top view of the same point can be done or can be marked in our drawing, then first to do it. So in this case also what we are doing is we are first marking C dash as well as C. So okay, let's see the how it is being drawn. So first the XY line, and then the projector of A, that is the in which the projector in which the point C dash as well as C will be lying, not A. So this is point C dash and here it will be point C. C is 50 millimeter below the XY line, that is why the distance is high. Now what we do is, now we know that the end D is in front of VP and it is above HP, 50 15 millimeter in front of VP means it should be 15 millimeter below the XY line. That is the top view of C. That is the top view of D. Top view of D. Instead of this way, this particular line will be lying in this fashion. That is C is here and D is here. So C we have already obtained. C is 50 millimeter in front of VP, and D should be 15 millimeter in front of VP. So for the locus of D, we draw a line, a horizontal line, or a line which is parallel to the XY line at a distance 15 millimeter in front of VP. That is, this particular line corresponds to this line. So that is the locus of D. Locus of D as well as D2, both are the same locus. Now what we do is, we know the length of the top view. The length of the top view is given as 50 millimeter. So from C to D, it should be 50 millimeter. So what we can do is, we can take the radius 50 millimeter and then draw from C to D an arc of radius 50 millimeter. And this point is point D. So then we join C and D. So the CD will be the top view of the line. So this is the point D. So this is the top view of the line. So in order to get the top view, what we do is, first we mark the point C, then we mark the locus of D and D2. Then what we do is, we take the radius equal to the top view length, the length of the top view, that is 50 millimeter in this case, as radius, and then with the center as C, we drop a radius or an arc which is crossing the locus of D at a point small d. So this distance, this is then drawn as a dark line. So CD, it is the top view. Now we draw the front view line, I mean the true length line. The true length is also given. This true length is drawn in order to get the length of the front view. So we doesn't have the length of the front view. Instead we have the length of the actual line. The true length is given. So we go for the true length. So the true length line is given here. We know that the C is the index point, that is the point at which the C is always fixed. And the D2 should be lying in this locus. So with the 75 as radius, if you to draw an arc, you will get the point D2 here. So this is point D2. Now the point D can be projected upward, since the point D dash will be lying somewhere in this projector. We doesn't know where it is lying. So the point D dash should be lying in this vertical line. So like this is the point. This is point D, and in this line somewhere the D dash should be lying. We doesn't know where it is lying. Now from this line, this D2, we can find out D2 dash. D2 dash will be somewhere here. So this is the point D2 dash. This should be the point D2 dash. That is, this point corresponds to this point. D2 dash corresponds to this point. And then with the C dash as center, C dash D2 dash as radius, we rotate. We rotate the distance C dash D2 dash.
Excuse me, sir.
Yeah, please.
Sir, D2 കണ്ടുപിടിച്ചത് മറ്റേ കോമ്പസ് വെച്ചല്ലേ? അല്ലാണ്ട് വേറെ
Okay. Hello.
Sir.
Is it? Yeah. Okay. C-യുടെ ലോക്കസ് അത് ഇവിടെയാണ് വരുന്നത് നമുക്ക്. In this case, in this specific case, the C is away from VP. ആ condition ആണിത്. D is nearer to VP condition ആണ്. Okay. അപ്പോൾ C-യുടെ ലോക്കസ് എന്ന് പറയുന്നത് it will be somewhere here. Not somewhere here. It will be a line which is passing through C, and it is parallel to XY line. അങ്ങനെ ഒരു ലൈൻ ആയിരിക്കും കിട്ടുന്നത്. So locus of C, obviously you can draw. But right now we doesn't have any use of this locus of C. That is why we haven't drawn it. Okay, got it?
Sir, CC dash in the length എത്രയാണെന്ന് പറയോ? CC dash.
CC dash that is 50. അതല്ലേ?
അപ്പൊ CD കൊടുത്തൊരു കാരണം
രണ്ടും നമുക്കിവിടെ 50 ആണ്. See, the top view length is 50. അല്ലേ? The length of the top view is 50. As well as the end C is in HP and 50 millimeter in front of VP. So 50 millimeter in front of VP ആണ്. So that means this distance should be equal to 50. That is C dash to C. As well as CD should also be 50. This distance is also to be 50. 10 to 50 വരണ്ടേ? രണ്ടും സെയിം വാല്യൂസ് ആണ് നമുക്ക് ക്വസ്റ്റ്യനിൽ തന്നിരിക്കുന്നത്. That is why it is 50.
അല്ല സർ, ഞാൻ ചോദിക്കട്ടെ, നമ്മളിപ്പോ ഒരു CC ഡാഷ് ലെങ്ത് അല്ലേ അപ്പൊ CCDക്ക് വരുന്നത്?
അതെ.
അപ്പൊ പിന്നെ അതൊരു സിംഗിൾ
line. Okay. I understood your point. But the problem is in this case the locus of D is here. അല്ലേ? D is 15 millimeter in front of VP. It is given that D is 15 millimeter in front of VP. But D should be in this locus, in this line. Okay? Alle? Sheriyalle? Okay. In that case, if we take a radius of 50 millimeter and drop an arc, it will be somewhere here. It won't coincide with this point because this point C dash and D ഒരേ പോയിന്റ് വരാൻ പറ്റില്ലല്ലോ. രണ്ട് ലൈനിലല്ലേ, രണ്ട് ഹൊറിസോണ്ടൽ ലൈനിലല്ലേ?
അതെ സർ.
ഓക്കെ, മനസ്സിലായില്ലേ? ഓക്കെ. അത് തന്നെ ആയിരുന്നോ ഡൗട്ട്? അതോ if it was something else?
ഞാനൊരു സ്ക്രീൻ ഷെയർ ചെയ്യട്ടെ?
ചെയ്തോളൂ. Sure.
ഇപ്പൊ ഡൗട്ട് സർ ശരിക്കും വെച്ചാൽ ഈ ഒരു ഡിസ്റ്റൻസ് ക്ലിയർ ആണോ? കേൾക്കുന്നുണ്ടോ?
കേൾക്കുന്നുണ്ട്. പറഞ്ഞോളൂ. കേൾക്കാം.
ഇത് C ആണെങ്കിൽ ഇത് XY ലൈൻ അല്ലേ?
അതെ.
ഇത് XY ലൈൻ, ഇത് C. അപ്പൊ ഈ ഡിസ്റ്റൻസ് എന്ന് പറയുന്നത് 50 ആയിരുന്നു. 50 ആണ് വരുന്നത്.
അതെ.
നമ്മൾ ഈ ഒരു ഡിസ്റ്റൻസിൽ 50 ഏത് കോമ്പസിൽ എടുത്താലും ഈ ഒരു ഭാഗത്തല്ലേ വരുള്ളൂ? അതെ,
പക്ഷെ 15 millimeter in front of XY വരണമല്ലോ. 15 millimeter below XY വരണ്ടേ?
15 ആണ് ഈ ഇത് വരേണ്ടത്.
അല്ല, അത് 50 ആണ്. ആ ഡിസ്റ്റൻസ് 50 ആണ്.
ഓക്കെ.
അതിന്റെ താഴെ ഡിയുടെ ലോക്കസ് എന്ന് പറയുന്നത് ഏതാണ്? ഡിയുടെ ലോക്കസ് എന്ന് പറയുന്നത് 15 millimeter below XY. ഇവിടെ വരും. അപ്പൊ അതിലേക്ക് 50 വരയ്ക്കുന്നത് വരുമ്പോഴത്തേക്കും ആ ഒരു ആർക്കും ലൈനും കൂടെ ഇന്റർസെക്ട് ചെയ്ത ആ പോയിന്റ് ഇല്ലേ, ആ 15 millimeter ലൈൻ വരച്ചിട്ടില്ലേ, ഹൊറിസോണ്ടൽ ലൈൻ? ഹലോ മഹേശ്വർ, കേൾക്കുന്നുണ്ടോ? അപ്പൊ ആ ലൈനും ഇപ്പൊ വരച്ച ആർക്കും കൂടെ ഇന്റർസെക്ട് ചെയ്ത പോയിന്റ് ഇല്ലേ?
അല്ല സാർ, അപ്പൊ ഈ ഡിസ്റ്റൻസോ?
ഏത് ഡിസ്റ്റൻസ്? അത് 15 ആണ്.
ഇവിടെ 15 ഉണ്ടല്ലേ? ഓക്കെ.
അപ്പൊ അത് രണ്ടും കൂടെ ഇന്റർസെക്ട് ചെയ്യുന്നത്
ഇവിടുന്ന് 50 എടുത്തിട്ട് അത് ഈ ഇവിടെ ഏതിനാണ് മുട്ടുന്നത് അതാണ് പിന്നെ നമ്മൾ CD കൊടുക്കുന്നത്.
അത് തന്നെ.
ഓക്കെ സാർ. ഓക്കെ, മനസ്സിലായി.
ഞാനത് വരച്ച് കാണിക്കാം. ഞാനത് വരച്ച് കാണിച്ചു തരാം.
സാറിപ്പോ ഷെയർ ചെയ്തപ്പോ അതിന്റെ അകത്ത് സ്റ്റാർട്ടിങ്ങിൽ വന്നത് സിയും ഡി എങ്ങനെയാ ലോക്ക്?
ഇടയ്ക്കൊന്ന് ബ്രേക്ക് ആയി.
സാർ ഒന്നുകൂടി ഷെയർ ചെയ്തോ, അതായിരിക്കും. ഓക്കെ. താങ്ക് യു സാർ.
Okay, so let's start from the scratch. That's better, I hope. So first we draw the XY line. Then what we do is we mark then we mark the, first we draw the XY line, then we mark the projector of A, and in the projector of A, not A, sorry, it's C, projector of C, and the projector of C, then in C we first mark C dash. Since the distance of C from HP is 0, or it is lying in HP, the C dash should be in the XY line itself. So C dash is drawn. Then we draw, mark the point C. C is, it is said that 50 millimeter in front of VP. So C is marked. Now what we do is we mark the locus of D. Locus of D, it is 15 millimeter in front of VP. So the locus of D, that is 15 millimeter in front of VP, that distance we marked, and the locus of D also we marked. Now this is the locus of D as well as D2. Now we draw an arc with the C as center and the radius as 50 millimeter in order to intersect with the locus of D. And this point is point D. Now we draw another arc with a radius 75 millimeter, that is the true length, and the center as C itself. So in this case, we obtain the point D2. This is the point D2. Now from D, we draw a perpendicular line, that is the projector line. So the point D dash should be lying somewhere in this particular line. He doesn't know where it is lying. That we have to find out. Now we know that from D2 we can find out the point D2 dash. And this point, actually it is not marked as D2 dash, this point is D2 dash. This is point D2 dash. So from C dash D2 dash, we obtain the length of the front view. The length of the front view is here. So in order to get the point D dash, so here see A dash as well as B2 dash, then A B2 dash, A dash B2 dash, the same length is for A dash B dash. So we can rotate this C dash D2 dash in order to get the point D dash. So here we obtain the point, this is the point D dash. Now join C dash with the D dash. Now this is the front view. So now the front view as well as the top view is done. That is the projections. Now we have to find the true angles, true inclinations with HP and VP. The true inclination with the VP is already there. That is this, the inclination of this CD2 with the horizontal line. That will be the true inclination with the VP. And in order to get the true inclination with HP, we draw the locus of D dash. This line is the locus of D dash. And into that line, we drop a true length line. True length we already know, that is 75 millimeter. So we draw an arc of radius 75 millimeter into the locus of D dash. So that point is D1 dash. So the angle of C dash D1 dash with XY line will be the inclination of the line with the HP. So from this D1 dash we can find out the D1 also. It is actually not necessary to find out, but as a check whether our drawing is correct. So we can find out D1 and then we can rotate that D1 to D also. That also we can do as for a checking. So now the front view is given, top view, then true length. Here also it is true length. Yeah, please.
Over doubt today, sir.
Yeah, sure.
ഇന്നത്തെ CD ആണല്ലോ ടോപ്പ് വ്യൂ ലെങ്ത്, പിന്നെ CD2 മറ്റേ ട്രൂ ലെങ്ത്തും. പക്ഷെ ഇതിനകത്ത് ബീറ്റ ഇസ് ലെസ് ദാൻ 5 അല്ലേ?
അല്ല, ബീറ്റ ഈസ് ദിസ് ആംഗിൾ അല്ലേ? ബീറ്റ എന്ന് പറയുന്ന ഈ ആംഗിൾ അല്ലേ?
താഴെ
അല്ല, ഇവിടെ നിങ്ങൾ മെഷർ ചെയ്ത് കഴിഞ്ഞിട്ടുണ്ടെങ്കിൽ ദിസ് ആംഗിൾ വിൽ ബി ലാർജർ ദാൻ ദിസ് ആംഗിൾ. Okay. Yeah, it is always the same case. Beta is always greater than, or at least the maximum possible value is at least equal to, or it will be beta is always greater than 5.
Thank you, sir.
Yeah. Okay.
Sir, arc in the radius C dash D2 dash അല്ലേ?
ഏത് ആർക്കിന്റെ? ഈ ആർക്കിന്റെ അല്ലേ മോളെ? ഈ ആർക്കിന്റെ It is same as C dash D2 dash.
Okay, sir.
ഇവിടെ നമ്മൾ നോക്കിയാൽ മതി. സോ സി എ ഡാഷ് B2 ഡാഷ്, ഇവിടെ B2 ഡാഷിന് പകരം C2 ഡാഷ് D2 ഡാഷ് വന്നിരിക്കുന്നതല്ലേ ഉള്ളൂ. സോ B2 ഡാഷിൽ നിന്നല്ലേ ഈ ആർക്ക് പോയിരിക്കുന്നത് in our base figure. Yes.
സർ അപ്പൊ C ഡാഷ് D2 ഡാഷിന്റെ ലെങ്ത് ഒരു 65 ഒക്കെ വരുന്നത് കുഴപ്പമാണോ? അല്ലല്ലോ.
അതെന്താ കുഴപ്പം?
അല്ല ചോദിച്ചാണത്.
അതല്ല, അത് വരച്ച് നോക്കിയാലേ എനിക്ക് കറക്റ്റ് പറയാൻ പറ്റുള്ളൂ. ഇറ്റ് വിൽ ബി സംവെയർ അറൗണ്ട് ദാറ്റ്. 75 താഴെ ആയിരിക്കും, അത്ര എനിക്ക് ഗ്യാരണ്ടി പറയാൻ പറ്റും.
65 ഒക്കെ വരുന്നത്.
ഓക്കെ, അത് വരച്ച് നോക്കിയാലേ എനിക്ക് എക്സാക്ട്ലി പറയാൻ പറ്റുള്ളൂ.
സർ C ഡാഷ് D1 ഡാഷ് വരച്ച് ഒന്നുകൂടി പറയൂ.
C ഡാഷിൽ നിന്ന് 75 മില്ലിമീറ്റർ റേഡിയസ് എടുക്കുക, ആർക്ക് കട്ട് ചെയ്യുക. നമ്മളിവിടെ D2 കണ്ടുപിടിച്ചില്ലേ? Same procedure. Same procedure.
Okay, sir.
Okay. ഇനി എനിക്ക് തോന്നുന്നു ഞാനിതിന് വരച്ച് കാണിക്കേണ്ട ആവശ്യമില്ല എന്ന് തോന്നുന്നു. മോസ്റ്റ് ഓഫ് യു ഗോട്ട് ഇറ്റ് റൈറ്റ് ഇല്ലേ? ഞാൻ ഇനി വരയ്ക്കേണ്ട കാര്യമില്ലല്ലോ, ടൈം വെറുതെ കളയേണ്ട കാര്യമില്ലല്ലോ. എങ്ങനെ? വരച്ചിട്ടുണ്ട്, നിങ്ങൾ വരച്ചിട്ടുണ്ട്. സോ ദാറ്റ്സ് ഇറ്റ്. നിങ്ങൾക്ക് കാര്യങ്ങൾ മനസ്സിലാവുന്നുണ്ടെങ്കിൽ പിന്നെ വരയ്ക്കാന്ന് പറയുന്നത് ഇറ്റ് ഈസ് വെരി ഈസി. Okay, now finally what we have to do is we have to measure the things, that is the theta. Theta is this angle is theta, this angle is phi, this is phi, this is theta is already marked there. So theta, then here is phi, and finally you have to mark the dimensions also, 50, 15, then the true length, top view length, etc., that also you have to mark. So can you say the values so that others also can confirm, that is verify whether their values are the same or not? Front view length എത്രയാണ് കിട്ടിയിരിക്കുന്നത്?
66.
Not 6.7, it is 67 or 66. We are always using millimeters, no centimeters. Okay, so it is 66, 65, 66, 67. Yeah, it's okay. 1 millimeter, as I said, 1 or 2 millimeters difference is okay. That happens. Without drawing it, I cannot also say that it is whether it is 65 or 66. If we are using some softwares like what do you say, the drafting softwares, then only we will get the exact answers. Even if I draw it using scale and pencil, then obviously I'll also be having some errors. And if I use AutoCAD to draw this one, then I can say that the front view will be correctly this much value, or else I have to calculate it using the true length and then the angle. As I said, it is a function of the front view as well as the top view length. It is a function of a trigonometric function of the true length. So that way also you can find out the exact front view length, what will be the front view length. Front view length എങ്ങനെയാണ് നമ്മൾ കണ്ടുപിടിക്കാന്ന് അറിയോ? The length of the front view. Any idea? If you know the exact angle, this is phi. If this angle is phi, trigonometric function വെച്ചിട്ട് this length ഇത് കണ്ടുപിടിക്കാമല്ലോ നിങ്ങൾക്ക്. This length is CD2 cos phi അല്ലേ? This length, that length is C dash D2 dash, or it is same as C dash D dash. So the front view length is the true length multiplied by cos phi. And the top view length is the true length multiplied by cos theta. So that way also you can find out the true length also. I mean the length of the front view. That way you can verify. But in that case also, if we doesn't have the true inclinations, it is not given in the question. If we found out from our drawing, there is a possibility of error. error in measurement or error in drawing. So exact value may be varying from the 66 or 65 or 67, but around that value, around 65 to 70, that is okay. That is acceptable values. Okay, what is the value of theta?
Sir, verify
48.
പറയോ?
One second. Theta value എത്രയാണ്?
40.
40. 40 or 48? 48 degrees. 47. 48 or 47. Okay. Verify ചെയ്യുന്ന condition പറഞ്ഞത്. Now what we have to do is CD1 top view ന്റെ length ആയിട്ട് നമുക്ക് കിട്ടിയിട്ടുണ്ട്. From D1 dash to D1. We have already got it. Now CD1 lengthും CD lengthും same ആണോ എന്നുള്ളതോടെ ഒന്ന് വെരിഫൈ ചെയ്യാം. വെരിഫൈ ചെയ്യാൻ വേണ്ടിയിട്ട് take a radius equal to CD1 and drop an arc. ഒരു ആർക്ക് ഡ്രോ ചെയ്താൽ മതി. ഇഫ് ദാറ്റ് ആർക്ക് ഇന്റർസെക്ട്സ് പെർഫെക്റ്റ്ലി അറ്റ് ഡി, then our drawing is perfect. That is the way in which it is being verified. So CD1 റേഡിയസ് എടുക്കുക, ഒരു ആർക്ക് കട്ട് ചെയ്യുക. That arc should intersect at D point, or it should pass through the point D. That is the condition. Okay. Now 5. Yeah, 5.
28 degree.
28 degrees. Alpha
56 degree.
56 degrees. Beta
43 degree.
43 degrees. Okay, it seems okay, or some 1 or 2 degrees variation is okay, that we can neglect. Okay, shall we move on to the next or okay, we can break for 5 minutes. One example and then 5 minutes break. Yeah, please. Any doubts that പറഞ്ഞോളൂ.
വൈറ്റ് ബോർഡ് വരയ്ക്കാമോ?
വൈറ്റ് ബോർഡിൽ ഇനി ഇത് once more I have to repeat. Okay, sure. Why not? We can do it. So it is first let me remember all these values. 75 millimeter long true length, measures 50 millimeter front top view length, and the CA is HP and 50 millimeter. Okay. So first let me insert. Top view length it is 50, and this distance is 50, and here this distance is 50, this distance is 0. So this is the condition. This is my XY line. XY line. Now I'm just avoiding using a protractor to find out the perpendicular lines. So here is C dash. So this is C dash. Now 50 millimeter below that. This point is C. Now another line 15 millimeter below this line. So you have to use set square to draw the parallel line. I am just using the capability of the software. So now this is the locus of D. D as well as D2. D as well as D2 both are same. Now what we have to do is we have to find out point D. For that one, I have to take a radius of equal to 50 millimeter, and with the center as a C. With the center as a C, drop a small arc here. So this is point C. I mean D. This is point D. And from point D, again, I draw a vertical line. And this is the projector for D dash. Now with the, now I can join CD also. CD is the top view. The top view is here, CD. Now with the this one, I have to take another 7.5 or 75 actually, 75 millimeter, and with the C as center. This is point D2. So now from D2 draw a vertical line. This is point D2 dash. Dash. With the radius as this one. This arc, so this is point D dash. Now join C dash D dash using a straight line. So this is it. Now what we have to do is we have to draw the locus of D dash. Here is the locus of D dash. Now with the 75 millimeters radius. Again 75 millimeters radius. And with the C as center, draw an arc. So this is point D1 dash. D1 dash. Join C dash, D1 dash. Now from D1 dash, drop a perpendicular line to the locus of C. This is the locus of C. This point is point D1. Now with this radius, if we draw an arc, it should pass through C, D. If it is perfect, if our drawing was perfect, it should have been passed through the point D. There is a slight error, very slight error. So that's because of some measurement or some errors. Let's see that here is some error, some inconformity is there. Here also there is some error is there. So that's why it doesn't pass through the point D. Okay, is it okay?